How about it, Twitch? Am I streaming yet? Hey, I'm streaming. I'll go tell the world. Streaming game dev with a hashtag, because that's how people do it. And then I'll go post here. And I'll go here. All right. So, last week we left off with a setup where everything was sort of working. I turned this back on because I was describing it to someone, but I'll just turn it right back off. Poof. The whole thing was working, kind of. So this week what I want to do is polish some of the things that I'm not 100% on, and one of those is the thrusters. So, as you might know, as you might have noticed, sometimes thrusters fire in every direction. And the reason for that is because thrusters for rotation and for maneuvering fire, both of those fire as individual things, even though they're off the same thruster. So the right thruster might be firing to turn you, and the left thruster might be firing to move you, but the end result is that both thrusters are firing and it looks goofy. So what we're going to do is just switch it up a tiny bit. We don't need to do much, but the thing we're going to start with is we're going to make it so the thruster can orient itself. We actually already have code for orienting the thrusters using a separate rotor head, but for this we're just going to create a maximum offset, angle offset on the nozzle itself, and then we're just going to work with that. Public float max, there's no space there. Gimbal equals, and we'll just go ahead and make it like 30 degrees by default. Now the gimbaling is only going to be useful on maneuvering thrusters. I'll go ahead and bring it down to 0. I lied, because it's only going to be something I want on the maneuvering thrusters by default. So what we're going to want to do is grab all of these maneuvering thrusters and set all of their gimbaling to maneuver. There we are. Set all of their gimbals to 30. Perfect. Easy as pie. And now what we'll want to do is actually code that so that, it actually does something. That's a good thing to have happen. Right. We're streaming. Everything seems to be running. Just double checking since I didn't actually look in on whether or not the stream was properly working. Just kind of went. So what we're going to do is we determine the angle that we want to face. We determine the angle we are facing, but we also need to determine the angle we want to face. So down here in the maneuvering update, we've got this thing where it says float alignment equals mathf.clamp1 vector dot and delta normalize and thrust vector. So the problem is that our thrust vector, which I believe is just transform.up, what we need to do is align that thrust vector with where we want to fire. The problem is that transform.up is not inherently a great vector for us to align with, just because the basic idea here is that you can do a look at, and that will give you the vector forward, whereas this will give you the vector up, which is not really very good. Down here you can see that we have these debug lines that get drawn. We're going to want to go ahead and multiply those by 5 just so that we can really get a good sense of exactly what sort of thrust vectors we've got going on. There we are. And what we're going to want to do is we're going to want to create a toggle where we can use either up or forward. Actually, we may just want to use forward and screw everything else. Okay, so the reason that we don't use forward is because all of the modeling I did used up, just because of the way it gets imported incorrectly. However, I can always change the import so that it doesn't work like that, or I can use a different module, right? Let's go ahead and import using a different set of parameters. If I go up to the rocket thruster clone, okay, it's a clone, so I don't get the original. Here it is, there's the original. This is inside of small ships. Now, the two options are either I can switch this so that when it imports without the flip on the axis. I believe that's an option somewhere. Oh, maybe it's not. Oh. In that case, we don't have any options. What we're going to do is we're just going to manually change the angle on these so that they work. Well, what happened? Okay. So this is the environment. All of our small ship elements. I haven't looked at this in ages, but the thruster is one of these guys. What's going on here? Why can't I select anything? Oh, we're in edit mode, that's why. There we are. So, is this the thruster? Rocket thruster, there it is. So the rocket thruster has let's go ahead and move this whole arrangement. There we go. So basically, this is the rocket thruster, and you can see how this is aligned with what is here, an axis pointing straight back. But what I need it to align with is an axis pointing straight up. So fortunately for me, I should just be able to rotate it negative 90 degrees. That doesn't look like 90. Rotate Y, negative 90. Rotate Z, rotate Y, X, negative 90. There we are. I guess that is vertical. Just didn't look like it. So if I do this and then I apply that rotation, it will rotate all of those engines. The meshes themselves will change. And I can go back into here and you'll see that these get updated to just point in some ridiculous direction. Oh, they don't because they are cloned. That's right. So in order to make these work, we would have to redeploy them. We'd have to redeploy them anyway, right? So let's go ahead and pull out our prefabs, small ship call, ion thruster. I didn't realize we even had one of those. I don't think that I have any. I mean, that's completely here it is. Just because I don't want to have one that's pointed correctly and one that's pointed wrong, we're going to rotate that 90 degrees as well, because otherwise it'll be incorrect. So we'll take this rocket thruster. Here it is. Just drop it into the world. Boom. And you can see that we have an issue, and the issue is that the none mesh filter is what we're using here. The reason for that is because the stretchy mesh has been a little bit naughty. I think that it malfunctioned a little, but that's okay. We'll just drop this in here. And you can see that basically all of the internal objects are now pointed in the wrong way. So what we're going to do is we're going to go ahead and select them and move them into the new arrangement. Now the problem is that they are rotating around arbitrary points in space. And so I can't really have them properly rotate. Unfortunately, there is no way for me to say to rotate around a given location. So I just have to massage these until they're in the right spot. Which is something like this. Looking down here, it looks like that's about right. Close enough for our purposes. The only other thing that I really want to do is make sure that our volumetric lighting bounds, they don't exist anymore. But we use this light wrangler to contain all of the lights, as you can see. And that's a very important task. So once we've finished that, we can apply it. Now you can see that right now our thruster is firing out the top. That's because that's literally what we told it to do. We said that the thrust vector is out the top. Instead, what we'll do is we'll switch this to transform.forward. There we are. And now you can see that it's pointed the correct direction. But the ones here in the ship are now incorrect. And the reason for that is pretty simple. Those are no longer prefabs. Nested prefabs are still not a thing in Unity, although I've heard they're working on them. So what we need to do is pull these thrusters out. Come on. How come I can't click through this? Here's one of the rocket thrusters. And what we'll do is we will just delete it. And then we want the other rocket thruster, but I don't know where it is, and I can't seem to click on it. Okay, so there's actually 2 rocket thrusters that we want, so we'll delete both of those. And then this guy, we can duplicate him and drop him into the ship. We don't have to worry about the structural arrangement anymore. That's old. It's no longer necessary. So what we'll do is we'll just put them into a spot that makes sense for us, like this, and move them into the proper location, like this. And we can duplicate it and flip it over and move it up. There we go. And I think that's even Steven. The last thing we need to do is duplicate it one more time and flip it the other way for our reverse thruster. Now, the one thing I'm worried about here is I didn't check the thrust numbers. It could be that the thrust numbers for the ship itself had been modified, and we might now be running with completely incorrect thrust numbers. If so, we'll fix it. No biggie. So we'll delete that. And now let's go ahead and just give it a shot and see what happens. So that looks correct. But you can see that the thrusters we've got mounted in the jets are no longer functioning correctly. And that's because they're now pointed in kind of random directions. They're off by 90 degrees. And basically what we want to do is just change their orientation by that same amount. If we change it to local pivot, we should be able to just rotate them into the correct alignment, because these don't have any sort of mesh attached to them. They are completely invisible. So we don't have to worry about the meshes not working right. We just have to worry about their positions not working right. There we are. The only problem is that our debris, these particle systems, are now all in the wrong spot. So what we need to do is select all these particle systems and move them into the correct location. The good news is it's a little bit easier than you might think, because what we're going to do is we're going to go into debug mode, which gives us access to the local position, rotation, and scale. So we can set the local position, and then we can just try and figure out which direction it's supposed to be. For some reason, the icon isn't showing up, but I believe that's correct. The local rotation, I don't really know what the default is. Let's go ahead and just make it like this. We'll just go back into the normal mode here. I think I might have botched it. Let's go and just set this to 0, 0, 0. And select one of them. For some reason, I'm not seeing the... Oh, there they are. That was super weird. They were refusing to actually show up. Now, the other thing we've got here is I don't actually know what's visually going to be shown because I can't see them. And we've got an error here. Oh, you know what? I forgot to take out the physics components for these guys. So we'll go ahead and just apply that. So now they should all be fine. Yeah. So this is, I think, clearly 100%. No, it's... For some reason, it's not properly updating the particle. There we are. So you can see that it was off by 90 degrees on the y-axis. So we should be able to just rotate all of them into the right alignment, but the problem is that they are all going to be in a different default alignment. So what we're really going to want to do here is switch this over into debug mode and get these local rotations set up. You can see that what we've got here is a 0, and a 707. So we've got -70, yeah, blah, 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 blah. Now the problem is you can't copy this because they are just mean You can only copy one value at a time. The good news is there's only one value we actually have to copy. So we'll just go in and paste this into every single one of these. You can see it almost gets it right, but it kind of barfs a little bit. I think that what we might need to do is copy this one instead. And then what we can do here is just put in a negative paste. It doesn't seem to want to do it. Well, let's see whether or not this is correct. You know what? I'm just going to turn on emission for all of them and do it that way. So I'll be able to see what's going on. Oh, I set it to 50 so you can really see, right? And then we'll just rotate them all one by one because clearly I don't really know how to do the trick I was trying to do. It was not working out. So it's a shame. Ah! God damn it. There's something wrong with Unity. It's like doing some weird stuff sometimes. I think that's all not... I don't think any of those warnings are still being applied, though. So here we're just going to rotate this. Nope. Rotate it like this. Yeah? There seems to be an issue with the simulation, and I chose the wrong direction there because I thought it was the other one. There we are. So now these are all rotated in the correct direction. The question is whether or not this strafe jetpack is stored as a strafe jetpack. Yeah, okay. So we can in fact just apply this because this is not, the ship itself is not a prefab. So we're not doing nested prefabs anymore. But what we need to do is turn off the emission because these are not supposed to emit on their own. And I think that'll take down here as well. No, so I have to change these manually because they were marked as being. Oh, well, you can just say revert, right? Revert. Yeah. So we'll hit save and we'll hit play and we'll see whether or not this now works. So all I've really done for the past half hour is try and get these jets to properly fire in the direction they're actually firing. And you can see that they are basically working now. But you can also see the thing I was talking about where you get them firing in multiple directions and it looks kind of goofy. So what we're going to do is we're now going to implement this thing where they try and look in the direction that they are wanting to fire. So for maneuvering, there are two tasks. There is turning and there is strafing. So if we take a look here, our course change is the amount of turning that we want to do. So we get that as a course change 4x4, and then we get our vector as based on our current offset from the center of our, yeah. Okay. So this is a little bit interesting. This does not take into account... Hold on. I may have just been doing this wrong since the beginning. Our course change is how much we want to turn. And it's noted as a course change in the forward angle of the ship. So what we do is we take that course change and then we try to figure out how we want our setup to work. So we get this quaternion, which is just the course change as a quaternion. Our ideal offset is going to be the offset that we want to be at. So basically what I'm doing is I'm taking the amount that the ship wants to turn, and I am looking at where we are on the ship, and I'm saying, okay, if the ship wants to turn X amount, then we want ourselves to be at this new position on the new ship, based on where we are now. So if we're in the ass of the ship and we turn left, we want to be moved to the right. And because we have the delta, we can tell which force direction we want to push. Like if we want to be to the right, then we need to fire to the left so that we can move ourselves to the right. So this delta is the direction that we want our ship to fire. Let's go ahead and add that in here. The delta is the direction we have to fire to move ourselves into the new preferred location. Dotbow says, it's been a while. Glad to see you getting forward, which is either a very clever pun or a hilariously accidental pun. So what we're going to do here is this alignment determines how aligned we are with our current forward, because this is the thrust vector right here is forward, right? So what we actually need to do is try and align our thrust vector with our new idea of what our delta should be. Now the problem is that we have two distinct pieces here. We do the strafing separately, right? It might be worth combining these. Okay, so for now, let's go ahead and duplicate this entire function for reasons that will become apparent, because I'm going to be just destroying it and I don't want it to... I'll have a backup. Just because otherwise I'd have to revert code if I screwed this up, and that would be... I'd have to stop the stream to do that, and that would be annoying. So what we want to do is combine these elements. This delta is the direction that we want to fire. So now we're going to want to also do the strafing. So if we get the strafing, float alignment, so I'll just leave that like that. This is how the ship wants us to fire. So basically, we can get ourselves the strafe delta and the maneuvering delta as distinct pieces. And we can even get exactly how far we want those to go, which is probably just going to be a matter of multiplying that delta by some amount. For now, however, we'll just leave it as is. And then we'll just say delta plus equals strafe. That's our final thrust vector intention. This can get put back down here. Was that where it was? Yeah, it was right there. Because we're doing the maneuvering thrust separately from the strafing thrust, simply because the ship considers them to be separate. So even if we are firing at 100%, we're going to register that 100% with the ship as either thrust to move us sideways or thrust to turn us, but not necessarily both. And the reason for that is, even though it's not very physically accurate, it makes your ship feel snappy and spry. Cody says, hello. Hello. Dotbow says he's confused with English. Well, I just spent the first 45 minutes or half an hour of this stream getting forward. Like, literally, I switched all of the engines to firing forward instead of firing up. So, we've got ourselves our thrust registers separately into turn and strafe. Vector 3 ideal direction equals delta plus strafe. Ideal thrust vector. Let's gimbal. So actually, now that I'm thinking about this, this is a problem. We can't gimbal like this. The reason we can't gimbal like this is because, simply put, we do not have a we do not have a second transform. So if I turn our transform to be pointing the right direction, there's no way for me to tell how far it's turned because I do not have a parent that can serve as an anchor. I do, but then I have to save our local transform and then constantly check against what it used to be, and that would be a huge pain in the ass. Now, the reason I was doing it with mounts before, turning mounts, is because those can serve as the parent. And I'm not able to do that with this. So we're going to go ahead and get rid of the gimbaling for now. But what we're going to do is we're going to use our turn and strafe values here. We're going to want to get a final value that's relative to both. So delta plus equals strafe. Dot bow says that it was an accidental pun, which is fine. And so what we've got here is this delta, and we're going to want to go ahead and put this in both places, like so. Now, to be honest, this is going to end up making something kind of annoying because it results in a situation where our alignment will always be synchronized. We'll be maneuvering or we'll be strafing, but we'll always be doing both of those. I'm sorry, I'm talking gibberish as I'm trying to catch up with myself. Basically, our jets will now always be firing the same amount, maneuvering and strafing, and that is not going to be an issue. It may just be leftover garbage the way I used to do it. But you can see that we have really, really snappy maneuvering now and quite slow strafing. So we're going to want to make our maneuvering take longer, I think. But that should prevent us from having the issue we had before where we would have ships firing in every direction and it was just, the thrusters firing in every direction at once and it was just very silly. Yeah, that was pretty silly. So we're going to go ahead and not have that happen. X-Sarden stopped in. Hello! So let's go ahead. That's maybe a little too slow with the... Oh, hold on. Now we're super snappy with the turning. I might have to try and figure out what's up with the turning because it seemed like it was really slow and then it was quite fast. It might simply be that... yeah, for some reason it turns very slow at low speeds. But once you've started to accelerate, it turns quite fast. See? So there's something in how this is firing that's making it fire much more efficiently when you're moving fast, which is not how I want it to be. So we're going to have to try and figure out what's going on there. The problem is that there's nothing in here that sort of has anything to do with that, except it's possible that our thrust, when we start to turn, when we're at speed, we immediately chime in with some strafe thrust to try and get our forward vector to be our only vector. In turn, that will affect our ship's intention. It'll affect how we want to fire, because we now have a new vector. So our turn vector and our strafe vector get added together, and we get a strafe vector when we are turning at a high speed. So it could be that there's something about that. Let's go ahead and try some stuff out. What we're going to do is we're going to turn on debugging for our friend, this maneuvering thruster. And we're going to go ahead and put in some value, some stuff, to try and figure out exactly what's going on. And what we're going to do is we're going to just grab the alignment here. So if debug, then debug log alignment. And we'll add in the thruster as well. There we are. So that should help us out, and that we should be able to see what's going on. X Sergeant says, maybe you are multiplying turning with movement speed. Now, I'm not doing that. Here is our maneuvering thruster. It's the thrust magnitude, which is just the thruster itself, and that's just a magnitude between 0 and 1 times the thrust amount, times the leverage, which is how far it is from the center of the ship, and that also doesn't change per thruster. And then I'm dividing by 20. Up here, our maneuvering quantity is equal to that times 30 divided by mass. And then we get a synced maneuvering quantity. But that's just a lerp between the last frame's maneuvering quantity and this frame's maneuvering quantity. So that's not being edited either. Up here is where we actually do the rotation. And what we do is we do ship.transform.rotation equals look rotation, ship transform forward, pilot ring transform up. So that just makes sure we're not tilted. And then here, we do our new rotation, which is quaternion.rotate towards ship transform rotation, the new heading, and the synced maneuvering quantity, which is not a value that gets multiplied by your speed. But there is something that is definitely multiplying it by speed, or increasing it as our speed increases. So clearly there is something going on. And if we turn like this, here, you can see how the throttle goes to 1 and our alignment is at 0.9999. So what we're going to do is we're going to try to accelerate, and then we're going to turn again. Okay, so you can see that the values are still basically the same. The alignment is 0.9999. If anything, the thrust is basically 0 at these stages because we're not even on long enough to see that thrust happening. So that's very silly. Let's turn off debug and put some debug into the ship. Because it could just be that there is something with this ship control system where our maneuvering quantity is screwy. Why is it so dark in here? Hold on, let me open the blinds up. Oh, it's already sunsetting. All right, so that will tell us what the ship thinks it's getting. So let's take a look. 0 to 0, and then if we turn, we get 0.15, 0.17. So we're looking at like 0.15, 0.17, something like that. But you can see that we're actually dropping as we move. The thrust is falling off the closer we get, and that may be the issue. So we're going to accelerate, and then we'll turn. And you can see that now we're getting still 0.15 and 0.17. I did see a strange spike where it hit like 3. Oh no, that was 0. So, so even though we're now moving fast, well, no, we're not turning like the super fast turning we had before. Okay, so we are actually reaching like 0.3, 0.2. All right, so there is something going on here where we are getting like double values. So if I turn, I never get... Okay, so I get to 0.3 here as well. Is it just an illusion that we were... No, we were definitely snapping around real fast. Yeah, look how much... Or is that the camera? Oh my gosh, is it just that the camera snaps around? No. The whole ship... Okay, yeah, it hits like 4. So there's clearly something going on here because it's hitting 4 rather than 0.15. So somehow it gets really, really exaggerated. Let's go ahead and log every single one of our buddies. Close that. And have us see which of these thrusters is actually firing. If it's all of them or some of them, we'll just figure that out. Debug.log thrust.magnitude plus from plus position. It could also be that the leverage is radically increasing, but that would be very strange. let's just double check that. So the leverage is offset.magnitude. Offset.magnitude is figured out here. It's a transform.position minus controller.center of mass. I think that we already checked that this wasn't changing, but let's check it one more time. Oh, there's no more controller. There we are. I mean, there's no more component. There's controller now. So, hit play. And you can see that we are at 8.29. Let's see whether or not that changes. No, we're always at 8.29 regardless of how fast we're going. So the leverage isn't changing. It's something else that's causing it to fire. It might be that all of the engines are for some reason considered to be on. We're going to check that out here in a second. Turn this back off and then go over here and turn this on. Let's try and figure out which of these engines, if any, is giving us ridiculous values. So you can see here that we get 0.6, 0.7, 0.8, that sort of stuff, right? We're not really seeing a lot of values here. So hold on. We're not at the bottom, we're at the top. Here we are. So here you can see that all of the engines start reporting ridiculous values of 1,000. Let's go ahead and start over. For some reason, it decided that I didn't want to actually see what was going on in real time, which was not great. See that? Why is that happening? I want to see what's happening in real time, please. So here you can see that we're getting 100, 150, 200. Yeah. So it looks like it maxes out at about 200. But if we accelerate, it goes up to thousands. So something is going on here. The individual engines are all saying that there is now more stuff involved, and it's more just flat out thrust magnitude. That means that the thrusters themselves are reporting a radically increased amount of maneuvering thrust. Here it is. Controller maneuvering thrust vector times visual effect times max thrust. I bet visual effect is what's going on. Oh, delta dot magnitude. There it is. I'm multiplying it by delta dot magnitude. And when my strafe increases, that delta magnitude increases. So we'll make this a clamp mathf clamp 01. That ought to fix it. So I was in fact multiplying the turning with the movement speed, as the strafe movement speed, but it was weird. I didn't realize I was doing that. Yeah, now we're turning at a regular rate. This turning is not great in terms of speed, though, so now I have to re-increase it. Looks like I want to increase it to about that. Yeah. Dotbow says, why not VS? I think that that's probably the question I get asked most, and the answer is that in order to use the community edition of Visual Studio, you need to have a Microsoft account and be logged in. Most people they log into the Microsoft account using their Windows login, and therefore it automatically just works for them. I do not log in with Microsoft Central servers for any reason ever, and I don't have a Microsoft account, and I'm not willing to use anything that's tied to those accounts. So I can't use the community edition of Visual Studio. So that's why. All right, so let's grab some stuff. Oh, that sideways vector is really strong now. I might have to change that. Grab it. Grab it. Grab it. Yay. It looks like there is a bug in the way the arm works, which I'll have to fix eventually. I need to change the way the arm works anyway. So it looks like we need to check and see whether or not our thruster's strafe thrusting is working. So no, that's just supplying the max thrust. So the strafe thrusting always just snaps to full on. So that should be fine, assuming that our alignment is in the right direction. That might be the issue here, is it might be counting every thruster regardless of whether it's pointed in even vaguely the right direction. Yeah, so we can clearly see here that we're not using this alignment to actually check anything. Yeah, so here we're going to want to go ahead and say if alignment is greater than 0.2, do this stuff. Otherwise, we won't actually end up... all of our thrusters will cause us to strafe, rather than just the ones that actually cause us to strafe. Yeah, that's substantially slower. It is, in fact, 1/3 the speed, since only 1/3 of the engines are actually on. That was kind of fun, but I think the turning is still a touch too slow. Alboecha says, "Hi, Craig. Hello. We're touching up the feel of piloting in this universe. Yeah, that's a little bit better. I fixed some of the weirdities and made it feel a little bit more arcade shootery. And no longer will our engines fire in every possible direction all the time." Oh, that feels really good. Bonk. I should have listened to the giant wall of yellow telling me that I wouldn't be able to get through. I don't think I'll be able to grab this. Oh, I will. It's just exactly out in the open. I do need to have a new shader. The glowing shader is apparently really screwed up. So those right there are the things that are causing the whole system to suddenly turn dark. That's entirely because of the shading. The shader involved. I can't get an unlit shader or a glowing shader that has an offset. I can't specify when it fires because for some reason the default setup doesn't let you do that, which is really silly. I thought that the default material had all those options turned on. It does not. Dopao says he didn't understand my point about MS accounts. Well, the version of Visual Studio that's integrated with Unity is Visual Studio Community Edition, which requires a Microsoft account. Most of you already have Microsoft accounts, even if you didn't realize it. I do not. Elbowicha says the ship is much more responsive now. Louise says it feels weird that these debris don't have collision. Right now, the small debris have collision. The larger debris, I'm thinking about the best way to collide with something like that, simply because they are quite large, so it's hard for us to determine which part of them we're colliding with. So these we can just walk straight through, because I haven't determined the best way to collide with them. They're essentially boxes, so it might be worth trying to do a box collision technique. I can get closest point on bounds to a point, and then I can just do that as a sphere collide. Yeah, let's do that. Let's go ahead and try that out. So those are all game objects, and they are down in here, I think, somewhere. Panels. Here we are. For example, here's one, panel dented, and we got this cheap collider built into them, which I don't believe does anything anymore. Yeah, all it does is keep track of all the colliders. So what we actually need to do is to have this not just keep track of the colliders, but also get hit. The thing that's doing the hitting is this cheap collider pusher, which is here. Right now, this actually doesn't have anything to do with the colliders in question. We can go ahead and delete all of this stuff. We'll come back to it later if we want to. But what we need to do is we need to, this draw instance base, this is what does all the small pushes. Push the non-game object things. Now push the game object things. For each cheap collider C in cheap collider dot colliders. We're going to want to get bounds. So bounds B equals C dot bounds. Now you can see that C dot bounds doesn't actually exist. So what we're going to need to do is make it exist. Public bounds bounds. Here in start, we're going to go ahead and make these bounds based on our mesh renderer. So here I'll just say bounds equals, I guess I want to store the mesh renderer, protected mesh renderer MR. MR equals get component mesh renderer. Actually, we'll preserve that for later because otherwise it'll be a little bit annoying. Oh, no, wait. We do need to have it right up front. That's fine. Bounds equals mr.bounds. There we are. The bounding volume of the renderer, read only. That's fine, right? So I'm presuming that those bounds are in world coordinates. We will know soon enough. So what we need to do is get the closest point on those bounds. I'm actually going to put these outside of the loop. I don't believe this helps any. I don't believe that this makes it any faster, but or use any less memory, but these are structs. And for some reason, redeclaring structs instead of a loop has always struck me as being strange. I'm kind of worried that they do, in fact, have a cost to them. I'm an idiot. There we are. So what we want to do is transform.position here. Let's go ahead and put that outside too. So now what we've done is we've gotten the closest position on our bounds to our transforms collider here. The collider that we're using has a specific scale to it. You can see that here. What we're going to want to do is get that scale. So float range equals transform.lossyscale.x. And what we'll do is we'll say if closest dot magnitude, let's do square magnitude, it's a little faster. Range times equals range. If closest dot square magnitude is less than range, bounce. Now when we bounce something, we're going to want to push it, but we don't have the things for that ready yet, so we're going to do that in a minute. First we're going to go ahead and just log it. Debug.log bounce plus c.name. So Dotbow says, you may already be bored by me, but why is there no way to register ones? It sounds mysterious. I don't want to register. I don't want to log in with MS every single time I try and code. That's just ridiculous. It's on my machine. It's my software. I have zero interest in letting Microsoft know whenever I'm doing coding, and what I'm coding and what my errors were. So they can just go blow, and I will use MondoDevelop. It works fine, and it doesn't require me to log in anywhere. Of course, Unity does, and that's a point of contention, especially since Unity's login and registration service is incredibly bad. Like, holy shit, it is the worst registration service. So I really, that's the one thing I really hate about Unity. It just continually screws up. Every single time I open a project, their service checking up on me barfs, and I get red text all over my console. It's just miserable. Which is a big part of the reason I don't want to do it with Microsoft either, because I'm sure I would just get more red text. And that's all fine. So let's go ahead and see whether or not we're getting any bouncing. That's further away than I thought. Yep, I agree, Dotbow. It isn't every program problem. All these programs these days require me to be online and register and all that shit. But I am an old guy, and I don't like my program spying on me this much. So I regularly disable every single online element to anything. So I get really upset that some of the games on Steam don't give me that option. It's like, why do I have to log in with my Steam account? Just let me play offline. It's ridiculous. So this isn't happening. Let's check and see whether or not it's because the all cheap colliders isn't working. There are plenty of cheap colliders. So it might just be that the bounds in these cheap colliders are not in world coordinates. This is going to be 9,000 bounds. Public static int overflow temp equals 5. Overflow temp. What was wrong with it? Did I spell something wrong and didn't see it? Oh. Elboy just says he also has a problem. I think I already talked about that. All right, so here we can see that what we have is centers that are clearly in deep space, like 3,000 away and all that stuff. If we are going to select any random piece of debris, like say that one, we can see that it is in fact located is this local position? Yeah, okay, so the global position. I can't get the global position. I think that 3,000 is not a completely invalid option. Let's just drag it out and see. Yeah, 3,000. So that is correct. Those bounds are, in fact, in the correct position. And then here, we're going to want to have this be closest, and then we're going to go over here into Cheap Collider and take out this value, because we don't need it anymore. So here you can see that we are getting a continuous stream of updates telling us that we are quite a ways away. Let's maneuver on forward. Okay, so here you can see the problem. These closest points aren't, well, the closest points aren't changing. Oh, of course not. They're not changing because I'm an idiot. I forgot to subtract our position. I found the closest point, and then I forgot that we have to subtract our position. Because frigging obviously we have to subtract our position. We're just getting the closest point. That's not the distance between us. That's the distance from 0, 0, 0. All right, so now let's see whether we can bounce. Bounced. Good. So what we're going to want to do now is have something where those bounces actually take place. And that's going to require a dictionary. So dictionary int and then vector3 pushes, movement, velocities. There we go. And what we're going to want to do is add some velocity into this. Now, what we're going to need is to just go ahead and steal the same velocity system that we have in here. When we set up the velocities in here, moving objects, so we'll just call it the same thing in everything. When we set up the moving objects in here, we create these bounds, but I don't know where we actually... Here we are. Move object. So what we need to do is find out where this is being run. Here we are, range. So here it is, under push. That makes a lot of sense. Basically, I just want to get the same amount of range here. So range equals position A minus pusher.position. If range.square magnitude is, yeah, that's fine. And then we just say range equals range normalized times max range divided by 4 plus pusher velocity divided by 2. And that is the value, the magic value that we use at the moment. We can change them later if we want, but for now it's fine. So what we're actually going to do here is invert this. Just because that way we don't have to go in another divot. Dapa says, sorry for made you angry. No, I'm not angry. I'm annoyed at Microsoft, but I'm not annoyed at you. I'm annoyed at Unity, but I'm not annoyed at you. I just wish that lock-in wasn't such a big part of every program on the planet these days. It's really terrible. Okay, so what we actually want to do here is we will go ahead and rename this to range. No, wait, we can't do that. That's fine. We'll just leave it as closest. And then here we have a max range, which we just call range, divided by 4 plus the velocity. Now, the velocity is just here. There we are. And so what we're going to want to do is make this into our moving objects, which we'll do by just calling the same kind of thing. So push A and then closest. So the thing is, there's no A. For int A equals 0, A is less than int call count equals cheap colliders dot all cheap colliders dot count. Now I know that this is actually going to save because this has to count every single time that hits the loop. So it's actually a substantial savings if you cache that, even though it seems kind of silly. There. So we don't have a push. Let's create one. Public void push int obj index, and yeah, and we'll also want to keep track of vector3 velocity. Now when we are pushing here, when we use the move object, we actually add it in. So that means that we end up pushing harder and harder and harder, which I guess is fine. We'll do the same thing here. There we are. But what we're not doing is actually using these moving objects, so we're going to go ahead and have an update moving objects call, which we'll put at the end. We're going to need a second dictionary of int vector3s, which we're going to call next, because we can't modify the dictionary as we are doing it, you know? It doesn't work. So what we're going to want to do is just subtract, move through all of them and then subtract a specific amount. So for each key value pair, int vector3, key vp, in moving objects, what we're going to want to do is just set this up as, do I really want this to be a vector3? Yeah, I guess I do. Sorry, I was thinking about the best way to do it. So what we're going to want to do is we're going to want to take that cheap collider, all cheap colliders, and then we're going to want to put in the index. Now, why am I using an index here? I could use a link to the game object, and that would be a little bit better for most purposes, except I'm not at all sure that I'm going to keep these as game objects. We're using ints because we may switch to not having them as game objects. The downside of using ints is that if that is rearranged, then we'll be pointing to the wrong ones. But the chances of that happening mid-bump is relatively low, so we'll be fine. Position plus equals kvp, kvp. Okay, so why is this barfing? Oh, because I put int here instead of kvp.key. So that moves us around, but we're also going to want to have this be transform.position. No, we'll just go ahead and do it like that, position. And then what we can do over here in cheap collider is have that be a reference. So public vector3 position get return transform dot position. No, it's not put, it's set. Transform.position plus equals value and update bounds. We can also put all of this into the cheap collider setup if we would like. Putting it all out here seems a little bit odd, so let's go ahead and do this as a static set here in the cheap collider. There we are. So this will do the same thing, but now it's going to be here rather than there. And what we're going to want to do is we're going to want to change the values here to slowly degrade them. Float val equals kvp.val. And then we'll say val, it's a vector 3, sorry. And then we'll say val times equals, or even val. Try to figure out the best way to do this. I guess we'll just use a lerp. Vector3.lerp, val 0, and then time.delta, time divided by 2. Divided by 5, like this, yeah. If val.magnitude, or val.square magnitude, why not? Is greater than 1, or greater than 0.3, something like this, then we'll want to add it to next. Next.add kvp.key, comma, val. And then down here we say moving objects equals next. Moving objects equals next. This is a static. And then down here in the cheap collider pusher, we're going to go ahead and refer to the cheap colliders for this. Called by the pusher. Yeah, that ought to work. Only thing we're going to optimize here is if moving objects.count equals 0, then return. Because we don't really need to worry about that. We're also going to clear out moving objects here. I think that will help the garbage collector, but I'm just kind of waving my hands at that. The problem is I'm really pushing to optimize this because it happens every frame, and that is a little bit expensive. Not a little bit expensive in terms of indie game scales. Normally indie games are pretty inefficient, but I need it to be fast because I can't afford to lose even 1 frame a second to this calculation. So it has to be lightning fast. Okay, so we definitely barfed. Got anything else? Interesting. I hope I didn't break something. We shall see. Let's go ahead and bounce off of something, see if it works. Shoo. Bounce. Okay, well, it worked. It looks like I added not a number to the speed here. So there's definitely something we're doing which is a little bit wrong. One of the things we might be doing wrong is this range might just be too high. So we'll put in this value here. And then we're going to go ahead and just do debug.log closest. So there are a couple of things that it might be doing that are causing it to have some problems. But we're going to go ahead and see whether or not it is a problem right from the start, or whether or not it is a problem that only becomes a problem after a couple of frames. Bonk. Okay. So that actually worked fine initially. So there's something wrong somewhere else. We're going to figure it out. Dappa says, I'm really interested in optimizing code and other stuff, but it's pretty complicated and different for each engine and platform. Yeah. There's a lot of things that I do that might not be even vaguely useful in C# because the compiler is different. So things like moving struct definitions outside of loops, I have no idea whether or not the compiler does that for me, or whether I am just doing busy work. So I need to know a little bit more about that, but I'm just going off of old instincts. So we're going to want to go over to Cheap Collider and have it actually debug.log moving objects index. Dappa says that sometimes optimization is about workarounds. It really does depend on how you do it, but I can tell you that this game would not be possible without optimizations, because one of the optimizations is the GPU instancing, and that optimization literally makes this game possible. Bonk. Okay, so I know what the problem is. The problem is that I'm moving it that full range every single frame. And I should be moving it according to the time.delta time. So basically, I was moving it 60 times faster than I intended. Still, it shouldn't have moved so far away from the origin that it would break. That seems a little bit strange. We will see here. I mean, it just vanished off the screen. It might be that the math is screwy. Okay, so yeah, they're just vanishing. What did I do wrong? Bonk. Okay, so here you can see that these numbers are not really that big. So I'm not sure how they're vanishing. Oh, there's the problem. Every frame, I was adding their position to their position, and then some small amount. And the result was that since they're 3,000 units away from 000, every frame they were getting 3,000 units further away from 000. Which is why they were vanishing, because they were moving at light speed. Bonk. Ah, that's better. So, as you can see, this does not take into account collisions with other objects. And I'm not really sure what I want to do about that, because collisions with other objects are a little bit expensive. But I could put it inside of this little loop here. So let's do a raycast. Raycast hit. Ray equals so Cheap Collider C equals this. Raycasts are expensive. They're not as expensive as you might think, but they are expensive. We're probably not going to do one every frame for each of these moving objects, but the thing is that you're not going to be moving a lot of these at once. You're going to be moving them only a small amount, and our ray can be a very short ray. So you're going to be moving maybe 6 of them at a time. That's not very many ray casts. And we're only going to be moving each ray cast by the speed it's moving. We're going to project like half a meter. It won't be very aggressive. So we'll take the c.position is new ray. C.position and kvp dot value dot normalized. And then we'll say if physics dot raycast ray, we don't even need the out hit. If we're going to do raycast and max distance of kvp.value.magnitude divided by 10, then what we're going to want to do is just not move it. We're just going to hit, okay, let's bounce it. Let's go ahead and bounce it. So for that, what we're going to need to do is actually separate this out so that we can adjust the value as it's moving. And what we'll do is we'll say val times equals -0.1. And that should allow it to bounce off in a fairly, not convincing way because there's no spinning going on. We may add spinning later, but that should work. Raycasting is the most usable function. It is not expensive that much. Yeah. People are afraid of raycasting because when they do raycasting, they get carried away. I've seen indie devs do like hundreds of raycasts and then complain about how expensive it is. If you're just doing a couple dozen raycasts, it's not going to affect your performance. Especially if you have a limit on how far the ray is cast. Bonk. Bonk, bonk, bonk. Let's go ahead and try and bump something into... Oh, see it? See it just stopped and bounced back? That's what I wanted. All right. So it's a little bit hard to separate out just by visuals the performance of the various pieces that we're doing here. Whoop. Whoa, no, I got stuck. Wasn't that fun? But we're not seeing a big amount of frame drop. I am seeing a little bit of frame drop, but I think that that's just because I am in the middle of a vast field of debris, not because of the bouncing that I'm doing. So these large objects can not only get bounced, but if they hit something, they'll stop. Now what we're going to want to do is maybe rotate those objects. So let's go ahead and... have that be something as well. Public void rotate vector3 axis float amount or angle. Transform.rotate axis angle. And then we'll make that world. Any barfing? You happy? It's happy. Good. So what we're going to want to do is tell it to spin as it moves, which we'll do just by having that be something that is just applied willy-nilly. We don't want to randomly do these things, which is initially why I was thinking about more than just a vector3. The reason that we don't want to do it randomly is because then it'll wobble through space, and that's really strange looking. So what we're going to do is before we update the position, we're going to go ahead and rotate. We're going to rotate around the axis of movement. So if we were to do that, it would be val, and then we will move val.magnitude times time.delta time. In terms of the number, maybe times 10. Now, the thing is, I think this is going to end up spinning us along the axis of movement in a really silly way. So we may have to adjust it or set it to local space, in which case it would really spin strangely, I think. There are a lot of other options, but let's go ahead and just see how this looks. Should look pretty silly. Yeah. Boom. Yeah. See how it gets a kind of weird rotation? That's really not what we want. So what we're going to try and do here is rotate around a different axis. The problem is that I don't really know what axis I want to rotate on. As long as it's not an axis which changes over time, it should be fine. But we don't want to rotate around something that is so obviously linked to the direction it's going. So rather than, well, first off, this is too big. We'll do it too. So rather than val, maybe what we'll do is we'll just pass it a vector3 dot up. That would always rotate it around the same way. That's not going to do it. Vector3 axis equals val dot normalized axis. And what we'll try and do here is maybe we'll say that axis.x equals axis.z. And we'll just see whether or not that does something fun. Shouldn't any axis normal to the movement of the axis work? I don't actually want it to be normal. I don't want it to be at 90 degrees off either. I want it to be random. But the problem is that random is annoying. That's kind of right. The question is whether... let's go ahead and just randomize it. So what we're going to do is public static vector3 random axes. And what we'll want here is a int axis equals 0. And then here what we'll do is we will just say int axis index equals 0. And then down here we'll say axis index plus plus. And then up here what we'll do is we'll say if random axis dot count is less than axis index, or wow, then random axis dot add vector3 dot random rather dot on unit sphere, and then we will just use the random axis. Alboecha says, is it just that the physically correct ones are too expensive? Well, there's a lot of problems with using the physically correct one. The first is I would have to know which exact point on the object I'm hitting. Now, technically, I do know that because I have the closest point of impact. So I could do that. No. So if I wanted to do it like this, I would need a dictionary that could take something besides vector threes, because I would have to take a rotation as well, or an angle axis at least. And then what I could do is I could take the position from the center of our bounds to the closest point on our bounds. And I could try and do an accurate. But I think that the inaccurate ones are probably okay. Just playing around with it, I'm not really getting this nasty feeling like, oh, these are so inaccurate. I'm really getting a pleasant feeling like, ooh, look at these things go flying away because I'm bouncing off of them. And that's really what I want. It's okay if it's not physically accurate, as long as it's physically fun. So I'm not too worried about getting them exactly accurate, but it's worth noting that we can get them accurate. So we should probably go ahead and type that in here. Note, because these are calculated, these collisions are calculated using closest point on bounds, we could actually calculate the real axis of rotation. But I'm a bit lazy. All right, well, this has been a fun hour and a half. I've fixed the maneuvering jets, and I've made some debris fly off in a more convincing manner. If you guys have anything you want me to do or to talk about, now is the time. For now, however, I'm just going to go ahead and plow through these and get a nice image of it. Crash. Oh, that wasn't very good at all. Let's try that again. I was going to take a GIF of it, but you know, in order for it to work, it needs to actually work. Yeah! Crash! Oh, darn it. I just remembered I changed the GIF capture settings, and now it's going to be more than 15 megs, so I have to fix that up. I don't know what the normal frames per second is for these GIFs. Dapao says it's too late for him to keep watching. Well, I'm actually almost done. So you are saying goodbye at just the right time, because this is the time in which I will stop. I'm just going to grab some last-minute screen captures for the sake of social media. That's... And we'll see whether or not that ends up being under 15 megs. Hopefully. I'm going to go ahead and delete my video saying that I'm streaming, since I'm not streaming anymore. Or at least I won't be very soon. While I wait for it to process. Okay, that wasn't a good... I don't know whether or not that is going to work out. Well, listen, I'm going to do this off screen because I might have to go and fuss with stuff. But thank you for hanging out, and I will see you on Wednesday if that's what you want to do. Bye.